Hello, Primary 7. Today we're going to continue learning about shape, and we're thinking about the properties of 3D shape today. Within this PowerPoint, I'm going to just review some basic regular shapes and talk about their properties within the 3D language. Okay, so we're going to start off with a cube. Now, a cube has 6 faces, and the faces on any shape are really the flat areas. So I can't count this because it's too tricky, and this is when a classroom would be easier because I would be able to show you an actual cube. But I'm going to do my best. So we've got 1 here, 2 here, 3 here, yeah? On the bottom there would be 4. On this side there would be 5, and on this side there would be 6, and they are the faces. We've got 12 edges. Now they are the flat lines, okay? The lines that connect the vertices together, they are edges. 8 vertices, they're the points, the corners. We had those yesterday with our 2D shape. On 3D shape, similar, they're the cornery bits. And the edges are all the same length in a cube because it would be the same square on each of these sides. We would have the same size on this side as on this side. All are squares within a cube. Yeah. So all sides would be the same. Cuboids, similar to cubes in that they have 6 faces. Remember, they're the flat areas. 12 edges, they're the length that connects the vertices together. 8 vertices, 8 points in space. And the edges, however, are not all the same on a cuboid. Okay, a rectangular prism. Now, actually, rectangular prism is just a different word for a cuboid. Okay, so they also have 6 faces, they have 12 edges, they have 8 vertices, so exactly the same as a cuboid, and the edges are not all the same. Different word, same shape, same 3D shape. Rectangular prism, cube. Okay, a sphere. Now, spheres are perfectly round, as you, I'm sure, are aware. They have no edges, therefore. They have no vertices, therefore. And they just have one curved surface. A triangular prism. Now, we're going to be thinking a little bit more about triangles later this week, and some of you will be thinking about triangular prisms within that work. Triangular prisms have 5 faces. Remember, the faces are the flat sides to a shape. So let's count them if we can. We've got 1 here and then 1 the opposite side, the triangular shaped face. And then we also have 3 here and then 4 on the opposite side and then 5 on the bottom. Now 3, 4 and 5 are all rectangles or potentially squares. Yeah, they're certainly not triangles. With a triangular prism you have 2 sides, so 1 and 2 would be triangles, and then shapes 3, 4 or 5 would either be a square or a rectangle shape. So we have 2 triangular faces, as I've just said, and 3 rectangular. Okay, square-based pyramid. Now, a square-based pyramid is something that some of us will be looking at later this week as well. It has a square base, does what it says on the tin, Primary 7. Okay, and it has 4 triangular faces that make up one sharp point. So there's 5 faces in total. That's 4 triangles, 1 square. Okay, we've got our cylinder now. We've got 2 flat sides, 2 flat faces, which are circular shaped. We've got 1 curved surface. Now, these are all regular 3D shapes, Primary 7. Okay, I just want to point that out halfway through, because actually, as we think about moving forwards with shape, we're going to be talking about regular and irregular shape. And there are no vertices. There's no points on a cylinder. A tetrahedron. Now, this is a triangular-based pyramid We have 4 flat and triangular faces. So all of your faces on a tetrahedron or a triangular based pyramid are triangular shaped. Some of them you might see are regular, which is this one, and some are irregular. We've got 4 vertices, the different points in space. So if we count those together, we've got 1, 2, 3, and 4. Oops. And then we've got 6 edges. Remember, they're the lines that connect the vertices together. A pentagonal prism. Now, this pentagonal prism actually looks fairly irregular to me in that it has one slightly longer side to the other sides. I could be wrong. I'd need to get my measuring tape out to be absolutely certain. Okay, so we've got 6 faces. Remember, the faces are the flat sides. We've got 2 pentagonal sides, faces, and we've got 5 other rectangular or maybe square-based faces. And in total, we've got 15 edges and 10 vertices. If you want to, you can stop the film right now and have a check on where those edges and vertices are. Okay, hexagonal prism, similar to a pentagonal prism. We've got 8 faces this time, 2 hexagonal faces and 6 rectangular faces, or as I said, they could be square-based faces. 18 edges in total, quite a lot of connecting from one vertex to another. So 12 vertices in total. Again, pausing the film, having a check where those vertices are and where the edges are. Okay, so here we have an octagonal prism. And what you'll realize as we're going through primary 7, you might have noticed already that from pentagonal to hexagonal, the increase in sides. So if we had our pentagonal, we have 5 sides, hexagonal, we have 6. Now we are at octagonal. Because the increase in amount of sides has increased, there will also be an increase in faces on your 3D shape. And that will also have an impact on the edges and the vertices. An octahedron. Now, I really like an octahedron. It's basically 2 square-based pyramids stuck together. Yeah, really interesting shape. They have 8 triangular faces. So all triangular faces on this one, 12 edges, 6 vertices. And they're just a fascinating shape. Okay, cones. 1 flat surface, which is a circle. 1 vertex, which is our point at the bottom or at the top, depending on where that cone is in space. And 1 edge. 1 curved surface that links the vertex with the flat circular surface. Circular face, indeed. Okay. A dodecahedron has 12 faces. Okay, so there are 12 sides. Some of you, if you would like to, have a think about what the shape of those faces are. Okay. In total, there are 30 edges. I feel that it would be really helpful to be able to hold one of these to really be able to count this. Okay, we have 20 vertices. Did anyone find out what the dodecahedron was? Yep, pentagons, all made up of pentagons. Okay. Primary 7, you have slightly different tasks today. All of them, however, are really identifying vertices, edges, and faces within 3D shape. I want you to think about looking at each of these shapes in really great detail. And I know that maybe some people will find that tricky because the shape isn't in front of them. So just try if you can, to find as many objects to help you out with that at home. Primary 7, the sheets that I have set you today are not interactable, and I'm really sorry about that, but the resources that I found just couldn't do that. So I would like you to try to write it down in the best way that you can. My suggestion to you is to name the 3D shape. Most of you are working on a grid system, so if you want to recreate a grid, that's absolutely fine. If not, you can always just write it down, and I promise I will understand what you've written. Okay, it's the content of what I'm looking at rather than the presentation today. So don't worry about how it looks, just tell me about that 3D shape, analyze its properties. Okay, primary 7, I'll see you again tomorrow for some more shape.